natural hazard research, natural resource management, specifically around biomass, bioenergy, and carbon. And the third component we really address is ecosystem service valuations, and how do you take all the other elements of what we really are interested in and combine them into some sort of meaningful information, and that's what I'm going to be talking about today. The title of the talk is really trade-offs between ecosystem services and fire hazard reductions. You don't necessarily need to think about them as trade-offs, but a way of combining a whole variety of information, some of which you heard earlier today and maybe on some of the previous webinars. So again, like Michael was saying, some of the slides are a little screwy here, so just bear with me. I'll try to fix the ones that I could find. Objectives, I want to give an understanding of what ecosystem services are, give you guys a framework, maybe come up with some a standard vocabulary to set this conversation going. I want you guys to be acquainted with some of the major tools and approaches and methods that people use for quantifying ecosystem services. We'll talk about that a little bit. I have two examples here where we're going to actually take ecosystem services, and in one example we're going to integrate it into a CWPP. How do you actually prioritize different treatments and fire hazard zones within a CWPP? And in another example, we're going to talk about how BLM used ecosystem services in assessing the efficacy of some of their treatment projects. And the last one, most importantly, I really want to highlight where you could use these sorts of things, what the limitations are, and just a general cautionary tale of, this is where it's good, this is where it's bad, and it's not a silver bullet. It's just another tool that you could use in your decision-making process. So what are ecosystem services? And you'll see that all the titles and stuff are going to be a little screwy, so just kind of deal with that for now. Well, ecosystem services could broadly be thought of as the things you get out of a healthy, functioning ecosystem. Things like improved water quality, timber production, avoided greenhouse gas emissions, or some sort of decrease in sedimentation. You also get some of these more abstract things, stuff like spirituality, healing, education, a place to ask your partner to get married at, a place to bury one of your parents. There's a variety of different things that these environments provide for us, and that can be quantified. One thing that's important to note is that you get different services at different scales, and those scales could vary both spatially and temporally, and understanding all those is important. So I figure I start with an example. And it's late in the day, and Carl's conversation was great, but coffee is something that kind of gets us all going here, and you'll probably need a cup of coffee after my talk. So that's the one I'm going to start with. So if you think about coffee comes from coffee beans. Coffee beans need some sort of pollination, and those pollinators need to live somewhere in some forest. And so looking at the Ricketts et al. Study, they looked into what the contributions were of pollinators or these pollination ecosystem services to the general production of coffee. Wow, some of these slides got reversed. This backward forest thing right here is forest. So he created a sampling design where he studied coffee plants that were put near the forest at an intermediate distance away from the forest, and then far away from the forest. And he wanted to look at how these specific variables impacted the production of coffee. I need to get rid of this green thing right there. And so on the on the x-axis right here for all of these guys, this is near the forest, this is far away from the forest. And what we see is that pollinators, when you're close to the forest, you have, increased richness. You have an increased number of visits from the bees. And you also have an increased you have increased pollination, and as you get further away for all three of these scenarios, those services decrease. Now, if you get into a situation, again, where you have close to the forest, far away from the forest, and these white triangles are what's happening in a natural setting, and these black little circles here are what's happening in a manufactured or structured setting where somebody's going in there and hand pollinating. You see, very different results. You see, again, in terms of the seed mass, how big the seeds are, the same expected trend that you see over here. You see a decline as you get further away, but when you start looking at what happens under the hand pollination scenario, it increases. Same thing versus the ratio of fruit to flower. As you get further away, you see a decrease in this ratio, and under the hand pollination scenario, you see an increase. And this last thing, there's a word over here that's missing. Right here, it's pea berry. That's what makes good coffee great. That's what makes expensive coffee expensive. And what you see in the natural setting, as you get further away from the forest, you get more of these guys. And in the natural, in the hand-thin setting, you get a decrease in the number of pea berries. And so what this is telling you is that, this hand pollination component is replacing a lot of the different ecosystem services that you're gaining by the hand pollinator, but there's a key one that you're actually missing. And it needs to be taken into consideration. And you could actually quantify different elements of these relationships. So, for example, if you wanted to look at forests produce bees. Bees allow you to pollinate, and then which increase the amount of coffee and the quality of coffee to the point where they were able to quantify that you will have 20% more productivity if you're within 1 kilometer of a forest. That's something that's useful and manageable and something that's quantifiable. Now, that's a very specific example, and you could probably sit there and say, hey, there's a ton of different examples like that, so you can pretty much quantify anything as an ecosystem service. And that's probably true, and there needs to be some sort of structure or organization to how these things get pulled together. And so during the Millennium Assessment, they created a framework for categorizing ecosystem services, and they came up with 4 basic categories. The first category are these provisioning services, and you could think of this stuff as stuff, wood, water, so on and so forth. The second one is these regulatory services, and these regulatory services are things like disturbance mitigation, things like different things that affect climate change, maybe a carbon project of some sort. The next one after that are these cultural services. These are things that people actually use the environment for, like recreational use or spiritual use. And there's an underlining one that link them all together, and these are the supporting services. And examples of this would be things like nutrient cycling or soil formation. And the way that you actually value these things also change. I mean, there's different ways of actually putting values on each of the different components. You could actually take market values, for example. You can quantify things in these non-market values, both using monetary methods and non-monetary methods, functional values. And then you have these generic externalities, and these externalities are things that aren't not necessarily a service by themselves, but they affect your ecosystem. Things like some sort of activity subsidy. That's not an ecosystem service, but it's going to change how those ecosystem services are functioning within the system. Like a restoration project, for example. Funding for a restoration project is going to change what you have in that system. You could also have a functional metrics, like some sort of pollutant that you're actually adding to your system. A lot of these things are easy to calculate. A lot of these things are hard to calculate. Calculating the value of wood is something that we've been good at for quite a long time. Forestry has that stuff pretty much nailed down. That method is pretty well established. Quantifying the value of dollars per hectare for some spiritual use is a lot more difficult to do. And so a lot more research is getting focused around that sort of effort. And how do you actually do that? What are some of the methods that people actually use? Well, you got these generic cost-based approaches. The first one is really these avoided costs. And what you could think of as an avoided cost is if you have a wetland, for example, and you get rid of that wetlands and you have a flood because of that, there's a certain amount of damage that you get from it, and that the amount of that damage is avoided caused by having that wetland in there. You could think about the same sort of thing with a wildfire treatment. So if you have a treatment in a location, an avoided cost would be the avoided cost of suppression, or maybe even the avoided cost of damage associated with a more severe fire versus a less severe fire. Replacement costs, these are the cost of engineering a solution. So for example, going back to that wetlands example, if you get rid of a wetlands, how much would it cost to build a levee to meet that flooding mitigation effect that it actually has, and how can it compare against the other functional uses of that ecosystem, of that wetlands within those ecosystem services? You also could use factor income or production functions. This is that example that we gave with the bees, for example. So if you actually put your coffee beans next to forest, it's going to produce 20% more coffee, and you could sell that coffee at a premium, and whatever that premium is the value of that ecosystem service. How much an environmental attribute are these ecosystem services are worth in bundled. And so one example are these travel costs. So you could think of like the whole Chevy Chase taking the family to Yosemite. How much are they willing to spend to actually see those sites? Another example are these hedonic pricings, and basically the way this works is it's very similar to when you actually want to sell your house or you want to buy a house. You might have a 3-bedroom, 2-bath house on a court, and you want to sell it, and your neighbor has a 4-bedroom, 3-bath house, and it's sold for $300,000, and based off of that price, you could say, oh, each bedroom's worth X amount of dollars, each bathroom's worth X amount of dollars. My house is worth a little nicer than theirs. And so you could start decoupling what those actual values are and come up with some sort of pricing scheme. Another approach are the stated preference approach, and this is it's generally like the willingness to pay. So you have contingent valuation. Most of the literature that you see out there is focused on contingent valuation, where people will come up to you and basically ask you in a structured setting, how much are you willing to pay for flood mitigation? How much are you willing to pay for recreational use? How much are you willing to pay for recreational use? A more organized approach using this stated preference is this choice modeling, as opposed to giving people just the option to pick whatever you like. It's the same basic approach, but allowing people to pick essentially from a list of potential options. You have biophysical measures. So this is getting out of more of these econometrics, environmental econometrics methods, to things that us as ecologists are more familiar with. These are things like quantifying the amount of biomass you actually have on the ground, quantifying things like canopy cover, quantifying like hard structured values. You could also use a variety of ecosystem models to quantify the fluxes, sequestration rates, nitrification rates. Maybe even some of these wildlife habitat occupancy models, the flux of those models over a landscape. And so then what you end up having is a whole suite of tools for valuing a variety of ecosystem services across the landscape that could all relate to each other. You have these revealed approaches, stuff like the avoided and replacement cost factors. You have these performance approaches, which are things like the travel cost and hedonics price. And then you have the non-market-based approaches, which are things like stated approaches, the contingent valuations, as well as a lot of the different values that we measure using traditional ecology. And then I think I'm pausing here if you guys wanted to chime in.
So if we have a couple of questions now, we can give them. But we want to tell people it's 3:21, and it's up to you if you want to hang on past 4 o'clock. I think Mike is suggesting that we do hang on past 4 o'clock if needed, and that the period after 4 o'clock, if we do go that far, would be for addressing some of the questions that we've gotten, rather than having to respond to them later. So, Carl, are you still there?
Yes, I'm still here.
Can you hang on a little bit beyond 4 today?
Sure, I can
Okay,
do that.
good. So we might try to do that. If we don't see the participants drop out at 4, then we'll probably try to answer the questions that we've queued up. So looks like Joe Christie's typing something here.
And I'll try to go a little bit quicker just so we'll have some time.
Well, you don't want to leave people in the dust either. I mean, some of this
Oh, no,
is pretty complex.
let me know if I'm talking too fast. I have a habit of doing that.
You're doing quite well, it seems, with the speed. So far, there's no questions for
Yeah,
David,
so let's move on because
continuing.
Joe Christie stopped typing. So.
All right, so what do we do with this sort of information? This is a lot of different ways of analyzing a lot of different things, and how do people typically do this? There's a BSR organized all the different ecosystem service valuation tools and approaches into these different scales like we were talking beforehand. You got these phase 1 sorts of assessments, and basically what that does is to reveal and prioritize generic ecosystem services that you can kind of think of as these larger overarching strategy tools. Some of you on the call might have heard of INVEST from the Natural Capital Program, the NatCap program, or ARES out of the University of Vermont. These are more quantitative tools in terms of quantifying the fluxes of ecosystem services across the landscape. ARES really does a nice job of that. Or INVEST is more of interactive expert knowledge approach where you actually identify things that you want to prioritize, and they have some really nice accessible models to actually quantify what those are on the landscape. And then you get into these more detailed, fine-scale, on-the-ground sort of measures where you're actually looking at the effects of a specific project. And Ecometrics has a variety of tools that deals with that. One of the ones I'm going to be talking about today is NACE, the Natural Asset Information System. Basically what it is a database of research that actually is used as information for all of these generic approaches. And basically the way it works is that it's built around this whole concept of spatial value transfer. And so if you have a study site, and that study site over here has certain ecological values associated with it, and you want to be able to take that study and transfer it from the original study to a policy site where when you look at it, it has the same sort of ecological values. And there's a variety of different tests and standards to actually make sure that the study site and the policy site, that transfer is appropriate. There's an assumption that the sites are actually similar. Like I was saying before, there is a test to make sure that they are. And there's also another assumption that as you gain more of these sorts of studies that are applicable to this policy site, the accuracy of this valuation will increase because you'll be able to hone in what that value is. And this is typically a static sort of assessment when you're doing it this way, where it's based off of a land use. So it's you do your study sites, you have your study sites, you create essentially a map of it, and then you take your values and you apply them. Now, if you wanted to make it more dynamic, you'd have to put in land use change models to actually accommodate that. So there's a few different steps to this thing. The first thing you would do is you would actually define your study area. Within your study area, you would actually develop your typology. That's just a fancy word for your land classification types. You would have to take into consideration the biogeophysical context. What do you actually have on the ground? What kind of vegetation do you have on the ground? What's it next to? Look at the socioeconomic context. If you do have, if it's an urbanized area or a rural area, suburban area, how are those anthropogenic areas interfacing or interacting with more of your ecological areas? And then the scarcity context. For example, if you're really interested in aspen, make sure you have aspen in your typology. If you're really interested in maybe a very specific sensitive species, make sure you have that in there as well. Then what you do is then you would go through and then you would identify all the different studies that you have for each of your land cover types, for each of the different ecosystem services of interest. And we call this a gap analysis because there's going to be a lot of stuff that's missing. We're going to be missing a lot of information in this sort of assessment, and it's very important to understand what you don't know. And so that's typically what you would do. When you actually go through and actually do that actual assessment, there's a variety of different things that you could actually link into. You could create a boundary around the geography that you want to actually look at. I only want to look at studies that occur within the United States. You could actually put a threshold associated with the quality of that study. I only want peer-reviewed journal articles from journals that have an impact factor of X or above. Or, hey, just give me everything. I want to be able to see the whole full gamut. And once you actually have that, then what you do is you look at those individual studies, and from those individual studies, you select the ones that are appropriate for your specific ecosystem service valuation method. And so, for example, in this one, out of the 19 studies that were found based off of that initial search, 9 of them were found to be appropriate for the recreation example. Then what you do, once you actually have those studies, then within the database, it finds the minimum value, the maximum value, and the average value per some unit per year. And that becomes the range of valuations you have for one specific ecosystem service, and you could actually link it back to a specific peer-reviewed article. And that gives you an idea of what you actually have on the ground. You take that information and you combine it with your mapping, and the mapping again that you're using is built off of the typology that you had identified early on in the project, so you could have a direct link with the studies that you're actually doing. And here's some examples of 3 different typologies we've created for 3 different areas around the country. And then you just start math applying those equations. So what was the value per hectare? How many hectares do we have within each land type? And you quantify it out, and what you end up with is total valuations for a specific type within a specific area. Here's an example of what it actually looks like for Southern Ontario. We just finished this project in 2010. We're releasing an update for it right now. You don't want to actually kick out a value, just the raw values. They're not typically meaningful by themselves. A lot of times you want to actually summarize it by some sort of geographic unit, either by a watershed or maybe by some sort of planning zone area, or maybe even some sort of management zone area. And we like to report the values out per hectare, per unit area. That way you have a weighted measure of what these things are actually or how they actually, what they actually look like. So that's the generic approach. Are there any questions about that?
Do we have some questions that people would like to see to move into your work you did in Nevada County?
Yeah, so now we're going to talk about some real examples. This is all great stuff, Dave. That's nice. I'm never going to do any of it. How can I actually use any of this stuff? How is it important to me? So there's 2 examples. There's the Nevada County CWPP and the BLM fire management assessment that we talked about previously. Now, for the Nevada County study, we actually did this in collaboration with the Fire Safe Council of Nevada County. You guys should know, or most of you guys know where it is. This is Lake Tahoe over here. This is the 80 right over there. And basically what we did is we did the elements that they were interested in is that they were interested in understanding what the fire hazards were for the region. They're interested in getting a better understanding of what the structure values were as a component of the assets at risk. They are very interested in understanding what the ecosystem service values were across the landscape, because there's a lot of evaluation that they thought would be important to integrate within their prioritization scheme. They're interested in the transportation corridors, specifically for emergency response, along with sensitive infrastructure that they wanted to actually prioritize. Those were the basic data analysis needs. That information went to a public survey. Once we actually did that information, we collected it, we sent it in for the public to actually prioritize which one of these things they thought were the most important. We also sent this sort of information for a fire chief evaluation. Connected to that, we looked at their planned treatments along with their completed treatments across the landscape. All that information went to a core team for evaluation, and out of all those different evaluations, we were able to create a priority scheme that went into the CWPP. That's the generic overview. So we're going to take each one of these things on one by one so you can kind of see how these things layer on top of each other. So the fire hazards there's two basic things that we looked at. We looked at crown fire activity, the surface, passive and active. We also looked at flame lengths. Those are the two basic variables that we went at. We used flame map to quantify this sort of thing. And again, I don't know why these words are backwards, but it had a bunch of vegetation structural data. It had your topography data, and you had your climate data. And then from that, we took what those measures were. We created an index, and we weighted it from 0 to 100. And you could see places where you had high fire hazard versus places where you had low fire hazard, and we compared this to other fire hazard maps that we had in the area. Second thing we did is we looked at the structural values. How much were things worth? And we tried to normalize that based on the parcel size. So if you had a really large parcel with a really large value, you received higher priority than if you had a really, really small parcel with not a lot of value associated with it. And you can kind of see the rule structure here, and if you want to know the reasoning for that, we could talk about it. But that essentially kind of gave you a weighted asset at risk matrix. The next thing we did is we quantified ecosystem service values using that same approach that we just talked about, the value benefits transfer method using NACE. And we normalized things on a per acre basis, where we saw things that were not worth that much per acre, and these values may be low for two reasons. The literature had low values for them, or there was no literature to quantify what the values were for the specific ecosystem services of interest. And then you had places that had much higher values, like these regions over here. And again, these things were normalized on a per acre basis. We took both the ecosystem service values as well as the structural values, and we had to create a way where we could compare them to other elements. And so we took the per acre basis that we actually had, capped it out at some value, and created an index that went from 0 to 100. We did the same thing for parcel values, where we capped everything out at $1 million per acre. If your value of your property was more than $1 million an acre, that became the 100%, and you went down. I think this one for ecosystem services, it was the $4,000 per acre was the max cap on that, and that really gave us two weighted surfaces that we could use in our priority scheme. The next element that we actually looked at was the emergency evacuation routes. And so working with the fire chiefs, we identified the routes that they prioritized the most. We took the routes, not only the routes, but we also took the placement of where those routes were located. And using some sort of algorithm, which if you guys are interested, I can show you how we actually did it. We buffered the roads out and then created a priority scheme where you had the most sensitive routes that were located on crests were given the highest priority. And some of these secondary roads were given lower priorities. Infrastructure, these are other assets at risk. And you'll notice that it includes a lot of things that are intuitive, like hospitals, fire stations, airports and schools, and some other things that we thought were kind of curious, like cemeteries, but those were things that were of interest that they wanted to make sure were put into the study. And so we gave each one of those things a priority value, and then weighted them as well using the same basic approaches that we just talked about. And then we took the WUI, the federal definition, as well as the local definition, which was a 1.5 mile buffer around urbanized areas and federal land, and gave those a priority. And again, we linked this back over to the parcel-based measure that we actually have. Now, since we have all those different layers, what we wanted to do is we wanted this thing to be an interactive tool. People could actually, we wanted to see how much people really valued environmental services in relation to some of these other elements. And so we held a variety of different workshops where we let people essentially give different priority factors. And so these ones, this would be like the roads priority, the infrastructure priority, the fire hazard priority, the ecosystem service priority over here. Along with it, what you want it to be rated out of. And so in this scenario, it's a 1 out of 5. How did you actually rate it? And then you would actually, it would produce a priority map for you. And when we did this, we found some interesting things. Like the core team, for example, for ecosystem services gave it a 6 out of 10. And they gave cemeteries a 3. That's pretty good. Their ecosystem services for the core team was worth more to them, or they prioritized it more than some of the property values, but less than maybe roads and what the actual fire hazard is. The fire department gave it a value of 4. They gave cemeteries a value of 3. They weren't too far off, but parcel values, structures, protecting life and property is, I think, a mantra that they pursue. And so you really see it manifested here, where the fire hazards was 7, the parcel value is 8. That was something that they really honed in on. That is along with the roads. How do you get out of there? The Forest Service, if you look at what they prioritized, it was ESV got a really, really high value. That and hospitals. Hospitals was probably the only thing that beat it out for the Forest Service folks. And when I say Forest Service, I should take that back. Those are people in the forest industry. So that would be people from the Forest Service. That would be people whose profession is dealing with forestry, like foresters and mill operators and folks like that. General residents, they gave it a value of 7. Again, hospitals 10, cemeteries 1. And the people who didn't self-identify, you'll see that they gave it a value of 7 as well. So when we ran all these different scenarios, what we ended up with is we ended up with a priority scheme that looks something like this, where ecosystem services are integrated into this overall values, but you still see the infrastructure and the property values taking a dominant role over a lot of it. And when we take this valuation and we normalize it by fire, you can start seeing where your highest priorities are popping up that are also linked to where ecosystem services are located. And then you can take this map and create thresholds, and we did that again working with the core team to areas that have a low, moderate, high, and very high index, and you can start relating that to placements of actual treatments, where you have planned treatments, these black ones, versus where you have completed treatments. And you can see how your previous treatments actually match up against your current priority scheme, and you could also use this information to help you prioritize the placement of new treatments. Now, I think I'm going to take another little pause before we move. The next example that we're going to talk about was a project that we did with the Bureau of Land Management, and what they were really trying to do was 3 things. They were spending quite a bit of money trying to look at the efficacy of their fuel treatments that they were putting on the ground. They were also wanting to see how much changes was actually occurring from a lot of their outreach activities. How effective was their education program and their fuels reduction program? And then the third component, the component that we're really going to focus on this little talk, is they were interested in analyzing how their fuel reduction projects were creating more ecosystem service valuation, or how did the ecosystem service valuation factor into a lot of the different efforts that they were actually conducting right now. So, a little background. BLM currently, or I don't know what's happening these days, this past couple of weeks, but they've been funding these community systems and hazardous fuel programs at the rate of $5 to $6 million a year. And if you go back to 1914, Chief Graves from the Forest Service made a statement that was, interesting and still holds to today, is that the amount spent on fire suppression should be proportional to the value of the resources being protected and the cost to protect them. And that's essentially what we're talking about here. Is that when we talk about protecting the forest, when we talk about protecting a lot of the ecological systems that we're interested in, what exactly are we talking about, and how can we quantify and put it into this context, because that's what's being asked of a lot of managers today. So again, trying to identify where we're going to actually do this study. We looked at all the different places where BLM had these programs, and we decided to identify 3 hotspots that we were interested in drilling down into. One of them was Humboldt, Nevada, and San Bernardino counties. For each of these counties, what we did is we went through and we looked at all the different treatment types, the planned acres, what the planned costs were, a full treatment inventory of what has been done and where they did it, what the costs were. Then associated with it, we went through, and again using the same benefit transfer methodology, because this is a very strategic project in nature. We're trying to find a high level effectiveness value on this thing. We did a land cover analysis. We did the gap analysis. Like we did last time, there's supposed to be a table here that shows you what the gap analysis really looks like. Things to keep in consideration: it's the upper bounds of an estimate. It's the lower bounds of the estimate, not the upper bounds, meaning that there's a lot of information that's missing. So this is like, hey, this is our minimum guess at things. For this study, we didn't include gray literature, and typically the values that we were coming up with underestimate ecosystem services based off of largely a contingent valuation methodology. And then we did the transfer, so we actually came up with all of our different land cover types, and we came up with a min value and a max value and an average value for each of the different cover types, and then we multiplied them out and summarized them by acreage. And again, I think this one over here is by watershed types, and we did it by zip codes to coincide with a phone survey we did as well. After that, we wanted to link that back up, again, with a structural value, so we did the same sort of structural analysis that we did in Nevada County to get an assessment of how these ecosystem services related to some of these traditional market values. And then what we did, and the interesting part here, is we tried to link it back to those actual treatment implementations. And so for this, we drilled down to 2 study areas. I'm sorry that this slide came up really ugly, but I'll try to walk through it. It's an important slide. Petrolia Valley and Morongo Valley. Petrolia Valley is a ecologically rich area that is relatively poor, rural poor area. Morongo Valley is the exact opposite. It's a relatively wealthy area that doesn't have a lot of ecological resources associated with it. And so within those study areas, there was 2 basic projects that were funded. One was a mechanical thin in Petrolia. The other one was a chipped biomass utilization in Morongo Valley, 85 and 76 acres, in size, so they're about the same size. The treatment cost, or the effective area, was about 10,500 acres. Again, that's pushing out where you think those treatments are really going to be able to protect. In one case, and 18,000 acres in another case. The project cost for Petrolia was about $28,000 versus about $70,000 for Morongo Valley, which gives you a cost per acre of $332 versus $941. Now, if you look at the structural values, this map that we were showing beforehand, that we spoke about briefly beforehand, you'll see in Petrolia, the total value that you have for that area is about $2 million versus $107 million for Morongo Valley. But when you look at the ecosystem service values, the non-market values, you see that the equation is essentially changed, where you have $4.5 million worth of value here versus about $400,000 worth of value here. Now, when you look at, when you normalize this per acres, you end up with these sorts of values over here, where it's like, the market value is $6,000 per acre. You can't compete with that. None of these other values are going to be able to compete with that. Versus the ecosystem service values for the Petrolia area is $436 worth, where it's virtually nothing on the Morongo Valley site. So if you're going to prioritize things based off of just the structural values or the market values at risk, the Morongo Valley project will get a lot more priority than the Petrolia Valley project, because this one you're doing at a loss. If you're going to look at ecosystem service on its own, in its own bubble, you'll see the exact opposite story coming up. But when you take them both into consideration, what you end up seeing that they both make sense, but they make sense for very, very different reasons, and those different reasons also need to be factored into the conversation. I had a planned break here, but I think I'm just going to just launch right through this. Ecosystem issues with this general approach. What are the problems with this approach, and where could this approach be really valuable to people? It's most feasible typically when you're inventorying land at a regional scale, landscape scale. It helps really build these broad scale policy changes. It's pretty feasible, pretty straightforward there. It gets a lot more difficult. You can notice my bunny slope, my intermediate slope scheme, little long motif here. It gets a little bit more difficult when you're actually looking at trading off specific land management alternatives. When you're trying to, that you're looking at both market and non-market values over a large area, you need to spend a lot more time and a lot more resources in doing those sorts of assessments. They're not easy. And the last one, your black diamond, where it becomes the most difficult, is really when you're trying to use ecosystem services at the site level where there's a real payment involved in. And at that case, it requires a much more rigorous sort of assessment than the two that I showed you today. These value transfer methods are great up here. Original studies are imperative down here. So if you're going to do something at this level, you need to actually get on-the-ground data and do an on-the-ground analysis. When you're doing your scenario analysis, what you need to do is you need to take these broad-scale approaches and link them into your field data and your local understanding. Yeah, and I spelled Petrolia wrong, I know. And so what's the take-home? The cultural and biophysical services are often at odds. You have these things called the island effects, and typically what happens if you think of a huge forested area, it has certain values associated with it. If you take a city and you smack it right smack in the middle of it, the values actually go up. As that city gets larger, the values go down. And so typically you need to have some balance with that, and understanding what that balance is critical and important. And that brings up some of the limitations based on decisions just using ecosystem services. If you're just quantifying what the service valuations were and not taking into context some of these other important issues, like some of these social issues and some of these economic issues, as well as some of these fundamental ecological issues, you end up getting yourself into trouble. And so, my other slide didn't show up either. So for prescribed burning, for example, there's supposed to be a green arrow. It doesn't show. You're supposed to have a green arrow up in this area facing up, and there's a lot of benefits,